Hey, how's it going? This is Mr. Hernandez, and I'm going over the notes for the correlation coefficient. So go ahead and pause this video anytime to catch up on the notes. But one thing we do want to acknowledge is that we use the letter R for correlation coefficient, and and also that there's different values that you can give for R, the correlation coefficient. And we just completed the Desmos activity, so I'm going to summarize the different numbers that you came across. Okay, so the first number you came across was a correlation coefficient of a positive 0.5 or 50 cents, if you want to call it, since it's a decimal. And so that would have been a positive slope, and the dots are kind of close to each other, kind of near the line. And so one way you could describe this is a positive slope. So there's a positive correlation coefficient, which is a positive slope, and the points are near the line. You could also have a correlation coefficient that is really, really high, close to $1, 0.99, and in that case, you would have a positive slope, and you're going to have points that are basically on the line, like really close. So this is another positive slope, and the points are very close to the line. Okay, you could have a negative 50, negative 0.5, and that would be a negative slope with the points kind of near. So you'd have a negative slope, and the points are kind of near line. And I should put kind of here too, right? So let's put that. And then you have a negative 0.99. In that case, you have another negative slope. And the points, again, are going to be really, really close. So the points are very close to the line. All right, so again, I'm kind of breezing through this, but you could pause it whenever you want. Now, you're basically going to have a spectrum of numbers. So draw a line across your paper, and you're going to go, it's going to be from -1 to 1. And so at -1, you're going to have a line, a negative slope, and all the points are right on top of it. That is called a perfect correlation. This is a perfect negative correlation. And then over here at the positive one, you have a positive line, and the points are right on that line. So that's a perfect positive correlation. Right here at 0, you're going to basically have no line, and all the points are just scattered. So that's no correlation. And as you go, here's 0.50. We already kind of did that. But if you have 0. The closer you get to 1, the closer the points are. So you can imagine, here, where it's like maybe 0.25, it's a positive slope, and the points are kind of far, kind of near. And as you go closer to 0.75, the points are getting closer and closer to that line. So this, you can imagine, would be called a weak correlation, a weak positive correlation. And as you go more to 1 or 1.00 or $1, that is going to end up giving you a strong correlation, a strong positive correlation when you're going this way. And then, of course, you could go the opposite direction. If you had negative 25, negative 0.25, you would have a negative slope, and the points are kind of not as spread apart as the zero, no correlation, but they will be pretty far apart. And if you had, negative 0.75, you would have a negative, and the points would be kind of closer together on that line. So this would be a strong, and this would be a weak negative correlation. And again, no correlation is all the points all spread apart. So if you look at this spectrum, you can see that the correlation coefficient is between -1 and 1. So it cannot go less than -1. It cannot go greater than 1. Those are perfect, and it's anywhere in between in terms of strong and weak correlation. The closer you get to zero, the weaker it's going to be. So this is weaker. And the farther you get from zero, the closer you go out here, that's where you get stronger correlations in the positive and negative direction. All right.